So today we'll be talking about examining access control vulnerabilities in GraphQL and REST API as well, and this will be a field case study on data exposure. So we'll be talking about this dating app called field and how the access controls in the REST API and GraphQL API impacted this app. So who am I? Senior pentester at 4Bridge, accreditations in pentesting, DevSecOps, and GCP security, and I've been working in the past in the banking and gambling industry, especially. I have more than 10 years of experience in security, especially pentesting. So what is this talk about? This talk is about the importance of access controls. And according to us, top 10 API, it is on the first place, known as BOLA category, Broken Object Level Authorization. And for web apps, it is also on first place, known as Broken Access Controls category in 2021. So as we can see, for API and web apps, it is on the first place, the access controls issue. Okay, let's see what is field, our target for research for the security of the API regarding access controls. So this dating app field launched in 2014 under the name of Trender. As the name implies, Trender, it was focused solely on threesomes. In 2016, because of a naming conflict, Tinder Trender, they changed their name to Fieldy, and they became more open to the idea of dating. So Fieldy is a dating app, just like Tinder, Bumble, and others, where you can filter by distance, by age, by gender. There are more than 10 genders, couples, and by location. If you buy premium membership and you're a premium user, you can also search by the type of kink you are interested in, three-ways, group scenarios, or the type of relationship you are interested in. On Android, it has more than 1 million downloads. So this is about Fieldy. Now let's see how this mobile app looks like. So we have four main menus. The first one, discover profile menus, where you get the name of the photos, the name, how far that person is and where is active, a short bio, and what the person is interested in. The second menu, who liked you menu. This is the view as a basic user. All you can see is the name and the blurred photos. The third menu, messages, where you chat with the people you matched with. And the fourth menu, my profile, where you upload your photos, edit your biography, and you can buy some premium membership. So this is how the Fieldy app looks like. Now, let's see what we will be talking about today regarding API security. So, I discovered 8 vulnerabilities in this dating app, all of them related to access control issues. We will be taking them one by one and discuss each of them. The first one is part of the broken object property level authorization, and the other 7 are part of the BOLA category. What's the difference between these two? The BOLA category refers to unauthorized access to a whole user, to a whole object, whereas the BOPLA category refers to unauthorized access to a specific property within the whole allowed object. Okay, let's take them one by one and see how to reproduce them and what's the impact for all these API issues. First one, disclosure of profile information to non-premium users. So as I said, we go to the who liked you menu. We see as a basic user, we always see is the name. Everything else is blurred. So as a basic user, we don't see anything. However, if we use a proxy tool such as Burp, we intercept this request and we check the response. We will see a GraphQL request with the operation name likes query, and in the response, we will see details about these people that liked us. In this case, we see imaginary name Sam. Interaction status, they liked us. We didn't like Sam yet. The status is active, so Sam is active, is not a majestic, meaning premium user. And we see a photo section. So if we copy the first photo of this user Sam and we paste it in the browser, we will get this photo of user Sam which belongs to this first photo blurred from user Sam. So as a basic user without paying for premium subscription, we managed to get more information than probably a premium user could get. Okay, so this was first vulnerability, disclosure of profile information to non-premium user. Another interesting field here for us that we can get is stream user ID, which is unique to every user. So this is for user Sam, and we will use this stream user ID value in order to build upon the next vulnerability. So vulnerability number 2, read other people messages. In order to do this, we will need the stream user ID from the previous vulnerability. To reproduce this issue, we go to the Discover Profiles menu. We intercept the GraphQL request, which will be with operation name Discover Profiles. And we will copy a random stream user ID, in this case ending with B4F, which belongs to user Clo, this stream user ID. So now to read the messages of user Clo, we go in the app to the messages menu. We intercept the request to the endpoint/channels. And from this request, we only leave the parameter members in and the stream user ID of our victim user called Clo. And in the response, we will find the messages of user Clo. If we search by text, we will see the first message saying, "Hi Clo." And in total, if we search by text, there will be 92 matches sent and received by our victim user Clo. Okay, now that we can read the messages of specific users, when we read the messages, we will discover in those messages that there are attachments. You can send in the app multiple attachments, such as photos and videos, and the photos can be replayable or time limited, and the videos can be replayable or time limited, play once only. So we have 4 types of attachments. Let's take them one by one and see how we can reproduce this issue. So to give you the high level overview, first, the photo gets, for replayable photos, the photo first gets uploaded on a third-party domain, then will be made available from 2 different endpoints for the sender and for the receiver to /photo ID. In order to exploit it, we go in the opposite way from the bottom, and we copy this, we leak this photo ID, we build these 2 URLs for sender or receiver, and because the backend doesn't even check the sender GUID or the receiver GUID, in this case we can just use an X or any letter, and the backend will just validate for the photo ID and return the photo. And then we will have as an attacker to leak this URL. So this is the high level overview from the bottom to the top from the attacker's perspective, and is the same, the high-level overview for the time-limited photos. First, a valid user uploads it on a third party, and then it will be made available to 2 different endpoints, sender GUID and receiver GUID. And after 10 seconds, this endpoint will be deleted, and we will have to abuse and create this URL. And then as an attacker, we will have to leak this URL in order to get it unauthenticated. So now let's reproduce the issue and see exactly how we managed to exploit this. So uploading replayable photos. First request, let's do this as a valid user. There will be a GraphQL request with operation name called Cloudinary generate upload credentials. It will generate some credentials for us, which will be used in a subsequent request where we upload the photo with those credentials. And then in a third request, I believe this request will make our photo available to the other 2 endpoints. And then it will paste the photo ID in the chat. So let's do this as an attacker. We log in as an attacker. We use the stream user ID of our victim to read their messages. and we see in the attachment section the photo ID that we want to leak from our victim. And we see that it is of type image and it is replayable. So in order to leak this photo ending in FF4, we will have to build the URL, FF4, and I said they do not even check who sent it or who receives it. So an X could work. And then it will just return the photo without checking properly the endpoint if it's the sender or the receiver. However, we will need to be authenticated. So now that we got the photos and attacker authenticated, let's see how we leak the unauthenticated URL. As part of the functionality of the application, there is an endpoint with v1 in front of it to this photo ID, which actually leaks us the URL to the third-party domain where we can access the photo unauthenticated. And this is what we did, and we have access to a photo unauthenticated on the third-party domain from my desk office. So that was just abusing their functionality. Okay, type 2, uploading type-limited photos. So there are two main differences from the previous process. First, we send an extra parameter saying visibility milliseconds, 15,000 milliseconds, meaning 15 seconds. And then in order to leak the photo in order of the previous X, we will need the sender's profile GUID to build the URL and leak the photo. Okay, let's reproduce again the issue. We upload the photo. We pass the extra parameter, visibility milliseconds 15,000. Now we read the chat as the attacker, and we see an attachment section saying photo ID ending in E49, playable duration 15 seconds, and replay mode view once only. So we copy this E49 photo ID, and if we paste it and build the URL, with, let's say, the receiver photo ID, because the receiver already saw the photo, it will say attachment has expired. So here we will have to use the sender's profile ID. So in order to leak the photo, we will need the sender's profile ID, and this will always return the photo to authenticated users. Then afterwards, in order to leak it unauthenticated, we just prepend v1 in front of the URL, and this will leak our E49 URL photo from the third-party domain, in this case, cloudinary.com. And this is the photo unauthenticated. Okay, this was for the photos. Let's see what's the process for videos. For videos, it's simpler. We just upload the video and we will get the URL from a third-party domain. The URL will contain /u0026, so we will have to change that for the ampersand sign. And this URL will be sent in the chat, of course. Then as the attacker, we read the messages of our victim, as seen here for our using our victim stream user ID. We see the attachment section saying that the attachment is of type video, the URL of the video where we have to copy it and exchange /u0026 for the ampersand sign, and that the video is replayable. So we copy this URL, put the ampersand sign where it's needed, and we will get a video unauthenticated from my desk office. So this was for videos replayable, and for videos once only, it will be similar, just that there is an extra parameter saying replay mode view once, duration 0, as seen in the response. We read our victim's messages as the attacker. We do the we exchange swap the 0026 for the ampersand sign, and again we get access unauthenticated to the videos that delete themselves. Okay, this is before and after the receiver sees the video once. So this is when you get a video, it says tap to view, and after you see the video, it will say video expired. However, all the videos are public online, unauthenticated. Okay, just to do a short recap, what happened. So in 2014, the app launched under the name of Trender. In 2024, at the end of the year, we published this, and this specific vulnerability shows that all photos and videos were available online without authentication, and on Android Play Store, the app has more than 1 million downloads. Now all the issues are fixed. Okay, let's continue. Vulnerability number 4, delete, recover, and edit other people's messages. So we discovered that we can recover other people's messages that were deleted in a chat. In addition, not only you can delete them, but you can edit and recover or delete them. Let's reproduce the issue. So the endpoint will be /messages/message ID. The methods will be delete and put. Okay, let's reproduce the issue, leave a message to someone, such as got any plans for tomorrow, and we will see the message ID will be ending in 8AD. We go to the endpoint, we delete the message, so delete method on this message ID, 8AD, and it will show 8AD, got any plans for tomorrow, meaning that it worked. So now if as an attacker, we want to read the messages, this message of our victim, we put the stream user ID of our victim, and it will say that the message ID 8AD, this message was deleted. So as expected, the app so far is working okay. But now, if we as an attacker, we apply the same method, delete, on this exact same message ID, 8AD, we got back the original message, got any plans for tomorrow, just by deleting it one more time. Okay, now let's try to edit someone else's message. We send a message, my phone number is 123, and it will say my phone number is 123 for the message ID 72. We read the messages of our victim. We see this message ID 72. The victim will receive a notification from user D, my phone number is 123. However, if as an attacker, we apply the put method on this message ID 72 saying my new phone number is 456, so completely something else, then this will be reflected in the response. And now when the victim clicks on the previous notification, it will see the new message. My new phone number is 456, saying below edited. However, the victim cannot know who edited that message, if it was the original sender or someone else. So it has no knowledge regarding that. Might have been the original sender. Okay, vulnerability number 5, update someone else's profile information. So you can update someone else's profile information, including name, sexuality, age, etc. The endpoint is /GraphQL with operation name profile update. Let's try this. Let's try to update our own profile first. So we are logged in as profile ID 91F, as shown in this header. We update our own biography saying ABCD, and then in our ID field, we swap our profile ID with that of a random user, 29C. And we will see in the response saying 200 OK, profile ID 29C, biography has been updated to ABCD. So that worked without an issue showing another access control missing. Now, another interesting vulnerability is get a like from any profile. So as details, you could send likes from profile number 2 to profile number 3 while being logged in as profile number 1. The vulnerable endpoint is /GraphQL with operation name profile like. So let's reproduce the issue. We are logged in as profile 29C, and we send a normal like from user ourselves, 29C, to user our test account 91F. And it will say sent. As expected, it worked okay. However, if we swap to send a like from user 91F to ourselves, it will say you cannot like a profile you own. So let's try to send from a random user to another random user to see if it works. And this is what we did. We are logged in as 29C, and we send a like from 6D3 to 91F, and it will say status sent. So that worked to control the like. And now let's investigate who is this user 6D3. We make a GraphQL request with the operation name profile query to query this user 6D3 to see who just liked us. And we see is imaginary name Annie, gender woman, age 26. And if we check our mobile app and we go to who liked us, we will see Annie, and I blurred Annie's face. Because I have a premium subscription, I can see who liked me. So this issue shows another access control missing. Vulnerability number 7, send messages in other people's chats. Vulnerable endpoint /channel /messaging /channel ID /message. We read our victim's messages and we find the channel ID ending in 0BD. We send a message to this endpoint, to this channel ID 0BD, hello from the attacker. And the victim will receive a notification from user B, which is the attacker. And in this chat is between user D and Bogdan. And the notification comes from a third-party user B. However, because in the app it allows you to change your name, these are not unique, so you can even impersonate one of the counterparts in the chat. So it worked to send the message in other people's chat. And the last issue, view other people's messages, endpoint /GraphQL, operation name chat list query. We can query our own matches, and if we search by imaginary name, we see that we have a total of 3 matches on our own account. However, if we swap the profile ID with that of a random user, let's say 91F, and we search by imaginary name, we see that this account has 45 matches. So this is another access control issue that is an access control that is missing. Remediation for developers, implement authorization checks between users. This must be on the back end and not front end. Implement user levels, and based on these user levels, implement access controls between them. For DevSecOps people, integrate CI/CD tools in the pipeline. However, for this specific category of issues, EDORs, it is very difficult to validate which profile ID is valid, which one is not, and is being abused. So this is very challenging to find such sort of issues. For CISOs, do data mapping, identify all personal data that your organization collects, including where it's located, and introduce measures to protect this data. For example, Uber was fined for GDPR violation for sending driver's license from EU to US, and TikTok was fined as well for GDPR breaches for sending European user data to China. Regarding remediation, we informed the Fieldy regarding these issues, and after 6 months, all the issues have been patched, and immediately afterwards, the blog was published. The research is fully available on our blog post. There has been a Guardian article on this issue as well, and the slides will be published on our GitHub. Now a short video in case okay, it's not available anymore. And Q&A in case there is any. If not, I will 1 minute maximum. Yes, please. I cannot hear you, sorry. That is a very good question, and it is very challenging to do that because, for example, let's take this issue, the other people's matches. Here is a request to check my own matches, which returns a response. Then I swap this profile ID for a different profile ID, and it returns someone else's matches. How do you identify in this response what's different from the other response? Because it returns matches. So you need someone's intuition to realize that you should not have access to someone else's response. So at the moment, I'm not aware of such a tool that can make such a comparison. In case anyone knows, please let me know. I'd be curious to find out.